How's it going, everyone? Today Vince, Niv and myself Wilson will be presenting you a video about vectors. Let's start with the introduction, background to vectors. First off, we have to know about scalar and vector quantities. A scalar quantity is a quantity that describes magnitude or size only, while vectors describe the magnitude along with its direction. To understand vectors a bit better, we have to talk about its origins. Meet René Descartes. He is known as the father of modern mathematics and the inventor of the Cartesian system. He is also a very well-known philosopher. One of his most famous statements was "I think, therefore I am," a very popular phrase in modern philosophy. Now let's go back to the Cartesian system. The invention of this system provides a bridge between algebra and geometry, where each point is represented by x and y. A vector can be represented in different ways. In words, for example, 3 kilometers at 40 degrees to the horizontal. Or by using a diagram. In the example seen, the distance of AB is also 3 kilometers at 40 degrees to the horizontal. Direction can also be represented in two different ways, either by using a true bearing or a quadrant bearing. Hence, the example seen in the video can either be at a true bearing of 135 degrees or a quadrant bearing of south 45 degrees east.
To determine the coordinates of a vector A in the plane, the first step is to translate the vector so that its tail is at the origin of the coordinate system. Then the head of a vector will be at some point A1, A2 in the plane. We only need to work with two of the ratios. It doesn't matter which two, but one of them needs to be one that we are finding for the missing length, because we know that both side B and angle B might be easy to work with. Now for the example, you would see that you have to find the side x, and you can do that by using sine law, where sine 51 over x is equal to sine 95 over 15. The law of cosine gives the value of one side of a triangle in terms of the other two sides and the angle included between them. In this case, we use a squared is equal to b squared plus c squared negative 2 times ac cos theta, where a is equal to 12. The sine rule is used when you're given either two angles on one side or two sides and a non-included angle. The cosine rule is used when you're given either three sides and two sides and an included angle.
Applications in navigation. A plane is flying at a heading of 0-30 degrees with a speed of 500 km per hour. The wind is blowing from the southeast direction at a speed of 60 km per hour. What is the resultant velocity? Let's start, but first we need to know, what do we require? First of all, let's summarize the available information. Heading 500 km per hour at 0-30 degrees, wind 60 km per hour from 135 degrees. Since we got that out of the way, we can now start our lesson in problem solving. Given that the angle from the vertical is 30 degrees, we can conclude that the inner angle is 60 degrees. In accordance to the zero, we know that this angle is also 60 degrees. The wind is blowing from 135 degrees, which means we are able to find the angle for the other side by deducting 135 from 180. Hence, we know the angle from the vertical is 45 degrees. Combining the two, we will be able to find the angle between the heading and the wind. Using law of cosines, we are able to find the resultant velocity. A squared equals to b squared plus c squared minus 2bc cosine angle A. Substitute the following values accordingly into the formula. Angle A, 135, magnitude of B, 500, magnitude of C, 60. A squared equals to 253,600 minus 60,000 cosine of 135 equals to 296,026.407. Magnitude of A should be 544 km per hour. Now we need to find the resultant bearing. Using the law of sines, we can find the inner bearing. Sine theta equals to 60 sine 135 divided by 544, theta equals to 0.56, bearing equals to 29.44 degrees. Last but not least, remember to write down your final answer, which is the resultant velocity of the plane is 544 km per hour at a bearing of 0 to 9.
So guys, we've reached the end of the video. We hope that you learned a thing or two. Thanks for watching and see you next time.